Hey Oz. Hey Madison. How are you? Good to see you, Oz. How was your weekend? Hey Lillian. Hey Madison Miller. How's it going? It's going okay. Gotta get click on my notifications so that I get chat messages because I sometimes miss them, and join messages because I sometimes forget those. Hey, there we go. 10 people. Hey Victoria. Shayana, how are you? Kaylee, Jeremy, good to see you. Christian, good to see you too. Right. You guys have a nice weekend? Tisha, hey, Kamaya, good to see you. How's it going? Good to see you. Guys are well. Anybody go to a football game last week? I need. What do you need? You said I need. Hey, Jalil, how are you? First you put I, and you put need, and then I. What's the third word? I need. All right. I forgot to tell this last period here. Let me do this real quick. Okay. So, nap. Pretty good. Pretty good. All right. So, guess what you get to do this week? Um, because Friday, if you look at the Friday page here, it says so we've got a Bohr atom, Lewis dot structure review, quiz review, and Friday is asynchronous teacher professional development. I got to learn about Naviance. All right. So you can sleep in on Friday. Okay. Right. Get to sleep in. You just got to get your 5 hours in. I will let you know though, if you are, if you are really needing sleep and you get your work done on Saturday, Friday's work can be done on Saturday and it counts as Friday. Saturday's work and Sunday's work counts for Monday. So if you want to get a head start, you can get some work on. So if you want to look at conference videos on Friday, um, but again, it's always good to keep in the routine. So get up early. If you're getting up early, stay getting up early. Right. So here we go, guys. We are going to start with um, today's Monday, 925 electron shells in the Bohr diagram. So it's a way to make the invisible visible. So sometimes it crosses over pretty well, makes it easier for you to see. I can't guarantee it, right? So the reason I say can't guarantee it, sometimes um, it uh, it gets confusing, but this is where we start to really start have to work hard. I have to say this: science is work. Algebra is work. So you put the work in, it shows that you're doing some good jobs on this. So it helps your brain put some wrinkles in there, not just wrinkles like I have on my face, but wrinkles in your brain. And sometimes it hurts a little bit, but it does require work. So for this, you probably are going to do this. I can describe the electron arrangement of the first energy shells. We talked about it last week, but if you don't know anything, that's okay. You can put that I know idea. I can draw a Bohr atom of the first 20 elements. Sometimes, it's like, oh, I don't know if I can do that, but you might be able to have some idea. And then we're going to talk about valence electrons tomorrow, so you should have no idea even at the end of this class. Okay, this class should go about 30 minutes, and then we'll have some practice. In this. So if you do that, and again, so hopefully I'm not having just 5 people in here that are working on this, because if you're not following along, and working on this. I keep track of that for bonus points, but I also keep track of it to see how that correlates or how that goes with your grade. No, most of the time, doing the assignments in class, doing following along has a direct relationship to having a good grade. Not always. I have some people that just for whatever reason they watch the videos and they can do it that way. We used to have a boy band several years ago before I was here that was on tour all the time, and they were doing their stuff at night. So something's. What did you draw? What did you look at? What I drew? Where? Oh, I see. Yeah, let me look. Yeah, that's true. I can do that. Let me. Yeah, that's right. This is a prompt. Let me go look. All right, open a new window here. It's taking its time. Okay. Oh, yeah, dinosaurs. Okay. All right. So, know a lot. So, there's a lot of information that this is going along with. So, let me turn my face this way so I can let you see better this. Okay, so we're going to talk about the Bohr atom. All matter is, so this review, okay, and this is the part that people have trouble with, is that we need to talk about protons being positively charged. We need to talk about neutrons being zero charge and electrons being -1. The type of element determined by the number of protons is the atom. So remember, that's what we said. We said this was a proton was the DNA. So one proton equals hydrogen. Two protons equals helium. Okay, so if I have one proton plus one neutron, one P and one E, that's still hydrogen. Okay, so if I add some neutrons to this, a couple of neutrons, still helium. It's the protons that make the difference between what it is and what it is not. Okay, electrons are negatively charged. Okay, so when I say, so from now on, if I say atomic number, you say proton. Okay, so I'm going to say that. Atomic number, put it in the chat. What did I say? Atomic number, what do you say? It says it right there. If I say atomic number, you say what? Nope, not 6, not 12.11. Okay, it starts with a P, starts with a P. Starts with a P. What is it? I'm going to put the shared notes here. Proton. Okay, everybody say that. Atomic number. You say proton. Put proton in there. Proton, not electron. Proton. Atomic number. Proton. Atomic number. Proton. It said it right there. Atomic number. Proton. I got electron from Christopher. Somebody else. Come on, guys. Oz, let's go. Come on, Christian. Come on, Jaleel. Put proton in there. Jeremy, proton. Jocelyn. Yeah, there you go. Proton. Proton. Come on, Jocelyn. Kaylee. Kamaya's already done it. Come on, Lillian. There you go, Madison. Thank you. So when I say, yeah, you say P. As atomic number, you say proton. Okay. So this is the atomic number right there. That's the 6. That means proton. This is the atomic mass, P plus N. Okay. So if I say atomic number, you say, oh, I got to look up the proton. Right. So that's the thing you got to remember more than anything else. All right, so review of electrons. They're negatively charged. We can draw them on as little circles on the Bohr diagram. The Bohr diagram looks like a planetary model. Planetary model looks like the sun in the middle, which is the nucleus, and things orbiting around. Okay, so the things that we're going to be talking about later, okay, charged atom, not neutral, is an ion. Okay, so notice that this is the charge on aluminum. That's considered a cation. Has a positive charge. And how it has a positive charge, I'll show you how it does. Okay, it has 13 protons and it has 10 electrons. And so it has 3 plus charges. So if I took 13 protons and had 14 electrons, okay, somebody do this. 13 plus a negative 14 and tell me what charge you would have. 13 plus a negative 14. Tell me what charge you have. You're get -1. Thanks, Ty. Yes, -1 equals -1. So that would be an anion. And we'll be talking about this later. But we just introduced it to you just so that you say, I've heard that. Mr. Gale's talked about that before. All right, so we're going to get into the model of the proton, but we have to make sure that our notation is clear. Number one, when you see a proton of 6, we also see on the periodic table 6 electrons. 6 protons, 6 electrons, because the way we're going to be talking about neutral atoms, not ions right now. We're going to be talking about neutral atoms. So proton of 6, electrons of 6. So don't get confused with the 12. Okay, it's always the smaller number. That's your protons, your atomic number. Right? I know Oz has fallen asleep. You can't do that. Come on, you get time for this. Missed the math class. I'm going to have you start telling your math teacher I'm doing science in math class. Don't do that. You're not getting any bonus points for me for telling me that. All right, so number of protons is the atomic number. Okay, protons equal electrons. Protons equals electrons. Okay, protons equal electrons. So atomic number, what did I say atomic number? What do you say? If I say atomic number, tell me what you say. Atomic number, who's listening? Atomic number, thanks, Kamaya. Protons. Okay, Kamaya's got it. My bad. Protons. Yeah, you can do next hour. When's your math class anyway? Hey, Donovan, good to see you. Yeah. Okay, protons. Protons, protons, protons. Okay, so let's do this one together. Right. Okay, tell me how many protons and neutrons in this particular one. Protons and neutrons. Here we go. I'm going to do this. I'm going to start the first one. Okay, there's my atomic number. Okay, so that means 3 protons. Okay, tell me what you got. Tell me what you're going to fill in that second one. I'll tell you how you're doing. Okay, 3 protons of lithium. Again, you're probably looking at me like, hey, Mr. Gale, I don't know. There's too many numbers there. Adelina's got on there. Let me get track of who's doing what on hour 6. Hour 6. Monday, Adelina. Thanks, Adelina. Where are you? There we go. My hour 6. Oh, I got it. And I know what happened. I want to put it. Okay, so Adelina's got 3. Oh, good job. You got it. And okay. How about electrons, ladies and gentlemen? How many electrons? Remember, it has to be the same. Okay. Well, it's got to be the same. So we've got to put. All right. So in order for this to be a neutral, we got 3 pluses and 3 minuses, right? So 3 and 3. Okay. Nope, not 3 across there, Jaleel. We're talking about just lithium. This is lithium right here. Okay. So we got 3 protons, 3 electrons. When we see 3 protons, we see 3 electrons. How many protons in oxygen? Put down a number for me. How many protons? I'm looking for the oxygen. Here's the oxygen. Lots of numbers. What number are we going to put in there? How many protons for oxygen? Good job, Christopher. You got it. All right. How many protons? Donovan, you're going to have to erase that. Oh, good job, Kamaya. All right. Good job there, Madison. All right. Anybody else? Okay. I think your computer locked up on your Jaleel because you put down. Okay, so how many electrons are we going to do? So remember, it's the same amount, same 8 and 8. Okay, so 8. So that gives me a neutral atom. 8 pluses, 8 minuses equals 0. Okay, go to the hydrogen. Show me how many in the hydrogen. How many electrons? How many protons? You got to put two numbers in there. They're the same number. They're the same number. Hey, Jaleel, if you can erase that, put the answer um, in the private chat because it doesn't look like it's working for you. Oh, good job, Donovan. Yep, got another number right after that. Okay, question. Okay, change the numbers. There you go. Kamaya, you got it. Go to the head of the class. Who else do I have? I've got Madison. Do I have anybody? Tyrese. All right. Okay. All right. So this one's 1. That one's 1. Protons 1. Electrons 1. It's like a tie score. You're playing football. Good job, Tyrese. Just change those numbers on the hydrogen. Okay. So I got Christopher, Kamaya, Tyrese, Adelina, Madison, Donovan. Who else did I get? Got Kamaya. Jeremy. All right, Jeremy. I was wondering where you were. Did you walk away a minute? Jeremy. Jaleel, you're stuck. Oh, there you go, Jaleel. Thanks, Jaleel. Your computer froze up on you. All right. All right. So we got 1-1. Okay. So, all right. Let's go clear out here. So Niels Bohr. Okay, so far what we've been talking about Niels Bohr, he did the atomic model. Now remember, before Niels Bohr, this is 1913. Okay, we had J.J. Thomson who thought it looked like uh, a dessert that had raisins in it and looked like a big plus and a bunch of minuses. He knew that it was neutral, right? He knew it was neutral, but he didn't know that how the arrangement of them. Well, Bohr says, well, wait a minute. I think they have separate orbits. Okay. And that's why we use the Bohr model because they have separate orbits. Separate orbits. No longer a plum pudding model. He said, well, you know what? Let's put the nucleus in the center like the sun. And it's small. And then let's put 2 electrons in the first first shell, 8 in the second shell, or 8 and 18 in the third shell. And they have a different way of doing about it. We got to fill the first shell first and then go on to the second, then the third. So he came up with shells and orbits. So the planetary model is what he came up with. That's what we use. Now, it's not perfect. It's a model. We can't see these atoms, so we just kind of have to we figured it out, but it doesn't always work. Now, the reason they say that is that atoms don't have they kind of do not orbit in a set orbit region. They kind of are found like in a cloud. They go really fast, um, and but they do only contain so many electrons in that orbit. All right. And if we were to be orderly about your graduation, when you graduate in 3 years, all right, we would have you sit in rows like the electrons do, and they would fill in the first row at the bottom first, then the second row after that, and then third row, that you fill them up in a specific order. Okay. And that's how they work it out. So we're going to be kind of drawing it that way today. We're going to be doing it in a specific order. All right, we're going to look at this guy's talking about the electrons. It's pretty quiet, and I'm going to give you the link and share copy. All right, so we're going to do this. So you do have control. I think there is a control in the lower left hand corner to turn the volume up. Does everybody know where that is? The lower left hand corner, should be a control for volume. Can you guys hear that okay? Anybody tell me if you can hear it? Hear it okay? Okay, great, Donovan. Thanks, Madison. All right, thanks, guys. So he had a specific way of doing things, and we're going to do similar to that. I'm not going to get too picky on it, but there will be when we get to Lewis dot, um, and tomorrow there's a specific way of drawing that that goes along with this. Okay, so let's try some more here. Okay, I'm going to skip that one. Okay, so again, 2, 8, and 18. Okay, that's your exit quiz. I want to make sure that you understand that 2 can go in the first, 8 can go in the second, 3 is 8 or 18. You can tell the shells are the rings. The first one is the ring. Some people were drawing on this and they weren't drawing the right rings. This is 1, 2, 3, 4, 4 shells. So make sure you can count those. All right. Now remember, again, the way they have this nucleus, first ring 2, second ring 8, up to 8, and so forth. So we're going to do this next one together. Come on, move on. Okay. Okay, here we go. All right, so follow along with me. Everybody circle the number of protons. Is it the 12 or the 6? Is it the 12 or the 6? Circle whether 12 or 6 is the number of protons. It's number of protons. Hey, Aaron. Hey, in the shared notes is the pair deck. If you can click on that. Okay, 6 or 12. Where did I go here? Whoops, not that. Okay, this one. Close window. Okay, I wanted to see who was responding. Okay. Right. Okay. All right. So thanks, Madison. You've got yours. All right. Christopher, you see what you got? All right. So what you should be doing, protons is always the smaller number. Okay. So you should be 6. Put 6 down. Okay. Put 6 down. Put 6 down. Okay. All right. Thanks, Jeremy. Thanks, Madison. Okay. Now here's how we do this. We're going to put, like he did, okay, I'm going to put a circle with a minus in it. A minus and a circle. That's what he's trying to do, to denote or to, and that's the first energy level. Okay. Some people thought this was the first energy level out here. The nucleus is right here. First energy level is right here. You put those first 2 in. Now we're going to go from the top counterclockwise or clockwise. Clockwise means going to the right. Okay, now we're going to put 4 more. Remember, we have to add total of 6 to make this neutral or equal to 0. All right? Neutral or equal to 0. All right, good job, Madison. Jeremy, you got those electrons to put in there. If you can't put them in there, you might want to. Thanks, Christopher. Got it. And thanks, Christian. Hey, Christian, I hadn't gotten you before. Glad you got here. All right. All right. It's good that you got back in here. There you go, Adelina. Aaron, there you are. Now, Aaron, you have to go. You're all in the same energy level. So you only can put 2 in that and then 4 on the outside. 4 on the outside. If you look at my thing there, my diagram, their energy level, it's the second ring. There you go. Moved them out. Great. And anybody else? I got Aaron. Adelina, Christian, Christopher, Jeremy, Kamaya, and Madison, and hey, Shayana. I didn't see you earlier. I hope I didn't miss you before. All right. Okay. So let's move on to the next one here. There's what it looks like. The 6 electrons. Again, what we're trying to get you to do is put the electrons in the first shell, 2 in the first shell, and 4 in the second shell, not all in one. Okay, so we're being a little more orderly on this. Okay, so, all right, tell me, all right, so in your circle the number of protons here. Is it the 23 or the 11? 23 or the 11? Circle the protons for me. Good job, Christopher. Okay, so if you circled the right ones, what you're going to do, let's just put dots in here. Let's first start with 2 in the first shell. Just put blue dots or whatever color you want, blue dots. Okay, right? All right, so now what we have to do after we've done, so you've got 11, right? You've got circled 11. So now we do the first one, then we go around this way. We start at the top of the second shell, put a dot. Then the next one down here on the side, one at the bottom at the 6 o'clock, and then one at the 9 o'clock. And then what we do is we double up at the top one. That's 6, 7. Oh no, that's 6. 2, 4, 6. Okay, we've got 8. 2, 4, 6, 8. And then we have 1 electron all by itself on the third shell. Okay, third shell. Okay, Aaron, 2 in the first shell, 8 in the second shell, and 1 on the third shell. Good job. Put a smiley face if you got 2 in the first shell, 8 in the second shell doubled up, and 1 in the last shell. Looks like you're doing great. 2, 4, 6, 8. You got yours. Good job, Christian. All right. 2, 4, 6, 8. You got yours good there, Christopher. You got yours good there. Oh, I like the different colors, Kamaya. Right. Shayana's almost there. Getting there. Tyrese, Ty, you've got it. Okay. So again, trying to get these into that order. So 2 in the first, 8 in the second, 1 in the third. All right. So again, 2 in the first, 8 in the second. I should have doubled these up on my key, so this should have really been, these should have brought these together. I'll have to fix that for tomorrow. All right, so this one, okay, so another way of looking at this, right? Proton plus neutron, proton. So some of you are still having problems deciding whether this is 3 or 6. This is the charge, which tells you that it's neutral. That means that protons and electrons are the same. Okay, so if I'm doing this one, right, and I'm doing protons in here, I've got 3 protons, 3 green protons. I've got, I don't think I can get gray in here, but maybe I can. There we go. 3 gray protons. Okay, and then going to the blue, and more purple. No, that's more pink. Okay. Then I got 2 in the first shell. That is not the color I want. Right. Let's go there. 2 in the first shell. and one on the second shell. Okay. All right. Remember, just a reminder, just a hint for you. Protons equal electrons. So looking at your periodic table, P table, where are you? P table. How many electrons do you see? I see 8. So that means you look at the proton count for 8. So how many have 8? Because if you see the electrons, it's considered a neutral one. Remember, go to number 8. And there you got it. Yep, you guys got it. Oxygen is that. So use your periodic table, just don't guess. Periodic table. So you've got 8. All right, so here I want to give you guys this link here. I'm going to give you about 8 minutes. Try this game. Click on the game. All right. Sure can. I can. Let me just get the link to people, okay? Where are we? Is that where you want me to go back, Ty? All that back that far? Okay, not a problem. Thanks for asking. All right, so you guys are on build an atom. Okay, try this one. Okay, so 7 protons. Remember, it's 1, 2, 3, 4, 5, 6, 7. That's nitrogen. And is it an ion or neutral? Remember, ions have more electrons or less electrons than protons, so this is an ion. C7 and 10, I know not many of you are hearing me, but if it has more or less electrons than protons, it's considered an ion. So give that a try. See how many you get out of 5. Put it in the chat. You can try it a couple times. I'm going to give you until 2:35. 2:35. All right, sure. Okay, so the next. Okay, so proton and electron. So it has one proton. What would it be? One proton would be what element? Give you a hint. It could be hydrogen or helium. Which one? Atomic symbol or game? Game. There you go, Oz. Yep. And will it be neutral, Oz, or will it be an ion? Nope. Remember, plus charge for the proton, minus charge for the electron. It'll be neutral. They cancel each other out. That is a neutron there, so that doesn't count as a charge. So you got positive proton, electron. Not a problem. Just practicing. How about this one? What element do you have here? Anybody? Anybody figure out what element this is? One proton in the nucleus. Nope. right there. One proton. So remember, hydrogen is 1, helium is 2, calcium is way down here, and this is 10, 20, 22 or 23, 23. So, yeah, hydrogen. Thanks, Joseph. I haven't seen you today. Good to see you. Is it an ion or is it neutral? Joseph, what do you think? Oz says it's ion. You're right, because it has more electrons than protons. How about this one? 10 protons. What is it? 10 protons. What element is it? Oh, you did. Good for you, Christopher. So answer this question. What 10 protons gives you how many? What element is it? One down. One down. That's 2. Yeah, there you go. Ne. All right. Is it neutral or an ion? Okay. 10 and 10. 10 and 10. They're both the same. Yeah, neutral. It's neutral if they have the same number of protons as electrons. Yay, got 5 out of 5. Okay, start over. Okay, if you want to start over and you want to get another challenge, this one tells you what is the charge on this one. Okay, if you want to move over to the other one, you can do charge. Anybody know the charge on 8 protons and 8 electrons? 8 charge, 8 protons, 8 electrons. Anybody have an idea? Yeah, it's 0, right? How about this one? 8 and 10 electrons. So you got to subtract them. 8 positive and 10 minus. 8 minus 10, okay, would be, I'm sorry, the mass number. I'm sorry, not the charge. The mass number is going to be, I think you were right. Somebody said 18. So you add 18, 10 and 8. There you go. I keep looking at it as charge. Yep, you're right, Jeremy, if we did that way. How about this? What's the mass number on this one? So we're wanting to find out how many things in the nucleus. Only how many things in the nucleus. So what's the mass? Nope. Just this. How many has in the nucleus? There's just one ball. So it's going to be 1. Okay. How about the charge on this one? Has no electrons, has 1 proton. Nope, nope. This one, yeah, there you go, 0, right. No, not 0. It's plus, okay, let me do it here and see if I can do it. Oh, it won't let me draw. Nothing here. So this is +1, and there's nothing there's no electrons, so this is a +1 charge. Okay, so we run out of time, ladies and gentlemen. I'll put that up for practice. Let's go back here. Okay, so what I'd like you guys to do, all right, so first off, let me do a quick review for you. Okay, so how many electron shells are there in here? How many electron shells in the chat? How many shells can you see? How many shells can you see in the chat? You could put down how many shells you could see. Not 8. Nope. Nope. That's electrons. How many rings? How many rings? How many rings do you see? 3. How many electrons can go in the first shell? How many electrons can go in the first shell? First shell only. 2. Good job, Kamaya. How many can go in the second shell? Not well. 2 plus 6 is not 5. That I'm not how many there are there. How many? Yes, Kamaya, 8. So there are only 2, 4, 6 in there, but you could get up to 8. So in the first shell, 2, second shell, 8. Okay, so what I'd like you guys to do, all right, we got, I'm going to give you this link here. Where are you? All right, pass, pass, pass. Got a few minutes left. If you can get on this one, control copy. You got a job. Fantastic. What kind of job you got? All right, so if you can get into that, right? This is the exit quiz. I need to get, let's see, you guys, I need to get 14 of you or 12 of you at least. So I need to get 51 responses. Make sure you get Power School 6, the Power School Physical Science 6, put your name in there. It asks how many electron shells here, how many electrons are in the first shell, how many electrons are in the second shell, number only, how many electrons, if you were to put those in there, how many electrons in the third shell. So you have to draw these out, look at your P table, right? But you also know that the protons will tell you how many electrons, okay? Right, so I need let's see, 39, 51 responses. If you can get that in there in the next 7 minutes. Okay, you want to make sure you have a piece of paper and you're drawing them out. All right. Oh, it says good job. I thought you said got a job. I'm sorry. I wasn't making any sense. All right, remember this is just a practice to tell me if I need to go over. Most likely I do need to go over it, but I need the information from you to see if you understand it and how many people I need to go over it with. So give it a try. It's not going to count against you. It just helps me in my deciding well how much more time I need to put in. Okay, right? Yep, Jeremy. This tells me it's kind of like I appreciate you asking for help. I want people to put in what they know. Good job, Christopher. 42. I need 9 more. Need 9 more people. I need 8 more people. Thanks, Kamaya. I could see that. You got 40. We got 43 now. We need 51. 51. So we need 8 more people. Hopefully not trying to confuse you. I'm just trying to figure out what you already know. Uh, how you guys are doing. Hey, I got Mariana, I got no. I don't know what the no was. Were you talking to me? Did I ask you a question? I don't remember. Did you get in your late, Mariana? I know you've had some internet issues. So 3 more minutes, ladies and gentlemen. My exit quiz. Oh, I gotcha. Yeah, I gotcha. Thanks. I forget. Sometimes I forget what I ask. All right. I got 49. Two more people, please two more people put that in there to let me know how you're doing in terms of how the exit quiz is what I need. I need to have proof, so to speak. Okay. My boss always asks me for proof. How are your kids doing? Do you have proof that they're doing well? Or is it just you say they're doing well? Okay, so I have to have proof. So we have to have exit quizzes. So I appreciate you guys responding to that. We got two more to go 50, 51. One more, one more, one more. And we'll go over it tomorrow. We'll look at the exit quiz and see, we'll go over it together and then see if that makes any sense. It might be that I just throw some questions in there and say, Mr. Gale, those are bad questions. What were you thinking at the time? It's like sometimes I have to say to myself,